So let us start the experimentation. So I have made an animation and hope you will like it and you understand the working. So when my frequency, input frequency is very less than the free running frequency, the PLL always enters into free running mode first. So as soon as we switch on the PLL always goes into free running mode first. So it is like the situation where the PLL doesn't pay any attention because input frequency not at all in its range, and that's why it will not attempt any action. So VCO will not do any action, and the control voltage, you can see that here the control voltage is 0 for this frequencies, and since control voltage is 0, VCO frequency will be equal to free running frequency. So that's why we say that PLL starts with the free running. So how long it will continue? It will say continue up to F1. So still it is free running. As soon as the input frequency becomes equal to F1, which is, now we can say that the input frequency is within the range of capture of PLL. So PLL can capture, and that's why PLL start paying the attention, just like the batsman started paying the attention. So PLL here actually initiates the action. So immediately it responds to the input signal, and as you see that input frequency is much smaller than F out. So this difference is negative, and that's why control voltage is negative and it is higher. So after this, if I continue to increase F in, the difference between F in and F out is continuously going to be small. And at F0, when input frequency exactly becomes F0, this difference is going to be 0. So that's why, as a function of input frequencies or phase shift between these two frequencies, the control voltage is also going to drop further. So this is happening in the capture mode. So capture mode starts at F1, where the PLL starts the action, and gradually this error goes on decreasing. So here the error was more, later it is reduced, then reduced, then reduced, and then reduced, and finally at F0, the error becomes 0. So this, at F0, we can say that PLL is perfectly established the lock. So here you can see, read the statement, capture mode initially unlock PL. So before F1, the PLL was not locked. We say that it is initially unlocked PLL, acquires the lock. So it is acquiring the lock. At F1, it started acquiring the lock, and at F0, it is perfectly established the lock. Okay. So there it can track the signal, and that's why VCO frequency also changes according to input frequency. And that's why you can say that it is perfectly locked. So later, if I continue to increase the input frequency beyond F0, what will happen? So now F in becomes greater than F0 or F out, and that is why the error now become positive. So you can see here the error is becoming positive now. So it will continue. Now how long this will continue to be in the capture mode? So as you see here, actually our expectation is that at F1 it has entered into capture mode. That means it should leave the lock at F3, equal distance or from the F0 to this side and this side. But there is a property called as hysteresis, and that's why once PLL acquires the lock in the capture mode, it will not leave the lock at the end of the capture mode, but it will continue to keep the lock or maintain the lock in another mode which we call it as a lock mode. So after capture mode there is a lock mode, and we define the lock mode like this. Initially locked PLL maintains the lock. So already the PLL has acquired the lock, established the lock. So already it is in the locking condition, but it is not leaving the lock. It is maintaining the lock at the end of or till the end of this lock. And that's why at F2, or rather after F2, it will leave the lock. That means it started acquiring the lock at F1, started tracking the input frequency, establishes the lock, and then leaves the lock at F2, which is slightly higher than this frequency. Okay, so because of hysteresis, it happens. So it will not release the lock exactly at the same distance away from F0, but it will take more frequency. It will require more frequency, which we call it as a lock mode. So in lock mode, it will continue or maintain the lock, and then after F2, again it releases the lock. Releasing the lock means again PLL enters into pre-running. That means VCO again stops the action, because now the input frequency is increased to a high level or to a large value, which cannot be tracked by the PLL. So there we say that PLL again enters into pre-running. So hope you have got the idea of the working of PLL. So right from free running mode, then capture mode, and then lock mode. So these are the three modes of operation of the PLL. So this is the forward experimentation. Let us do the reverse experimentation. Now imagine that now we have reached to the other end. Let us reverse this experimentation. So now I am plotting in the reverse fashion. So red will indicate the reverse path. So now I am here. Okay, that means input frequency is much larger. So we are now started reducing the input frequency. So first, always it enters into free running mode first. Look at this. So still now in the reverse path, PLL has not started the action. So how long it will wait for capture? It will not start at F2, but it will start at F3. So up to F3, the PLL will still continue into free running mode. And at F3, again it enters into capture. Started gaining the phase, so started its action. So initially the error is positive here, then come down, this error will reduce. So PLL has established the lock. Okay, it will establish the lock, continue to lock. Okay, at F1 we were expecting that it should release the lock, but it doesn't release the lock at F1, and it enters into lock mode where it continues to maintain this lock, and at F4, or rather after F4, it will release the lock. Again enters into free running. So always this flow is there. So free running to capture, then once it establishes the lock, it continues in the lock mode, and at the end of the lock mode, it releases the lock and again enters into free running. So hope the whole idea of how the PLL works is very clear. Okay, so let us quickly define some of the parameters of the PLL. So this is the same picture, same characteristics, transfer characteristics. So let us define parameters. So one is free running frequency, already we have discussed. This is the frequency of VCO. Okay, so in VCO, we can have the resistance and capacitance. We can choose that and we can set the F0. So if you see, it is always at the center. So we have to determine the free running frequency first. Then we set the capture range. So what is the capture range? it is the difference between F1 and F3. Okay, so capture mode start at F1 in the forward direction, and capture mode starts at F3 in the reverse direction, and that's why capture mode always it is between F1 and F3. So we call it as capture range. So it is 2 times delta Fc, which is difference between F3 and F1. So this is how we define the capture range. It is the range of frequency over which initially unlock PLL. So before that PLL was unlocked, acquires the lock. So it is establishing the lock. So one thing, it is acquiring the lock, that is capture range, and lock range is maintaining the lock. So understand the words. One is acquiring and another is maintaining. So second range, as you see here, is maintaining the lock, that is lock range, which is written as 2 times delta FL, okay, which is equal to Ft minus F2 minus F4. So these are the two extremes, F2 and F4. So in the forward path, lock was maintained till F2, and in the reverse path, lock was maintained till F4, and that's why difference between F4 and F2, so F2 minus F4 is the lock range. So these are the three important parameters that we have to see, or rather when we see the design or when we use the design. So in designing, always you have to find out this parameters. So first we set the frequency, free running frequency. Then we decide the capture range. Rather, capture range and lock range, these are the parameters which are IC dependent, PLL dependent, and they are always a function of F0. So later on when we see the equations, the whole idea of these equations will be very clear. So free running frequency, capture range, and lock range. So hope you have understood the concepts of these three parameters.